welcome to the Online Continually Course of TRAPSPOT 2020 held by American Association of Petroleum Geologists Universitas Pajajaran Student Chapter. Let me introduce myself. My name is Ainun as the Master Ceremony of today's activity. Online Continually Course TRAPSPOT 2020. With the theme is Introduction to Petrophysical Analysis for Unconventional Shale Reservoir. TRAPSPOT 2020 was sponsored by Petrochina, Chevron, Pertamina Hulu Simenggaris, and Medco INP Simenggaris, and also media partner by Radio Mahasiswa Unpad, Geologipedia, Event Mahasiswa 8, Bandung Event Bandung ID, GeologiNet, and Event Campus. Before that, I would like to say thank you to our invited guests, lecturers from the Faculty of Geological Engineering Universitas Pajajaran, and also alumni of AAPG Unpad Student Chapter. Thank you so much for participating in our event. On this beautiful day, we will have a lecture from Mr. Muhammad Nur Ali Akbar as a Petroleum Engineer at MOL Hungary. On behalf of the AAPG Unpad Student Chapter, I would like to say thank you to Mr. Nur Ali Akbar for willing to share his knowledge to all of us today. Now, I would like to tell you about the agenda of this meeting. We would have two sessions for this meeting. The first session will learn about the topic of Introduction to Petrophysical Analysis for Unconventional Shale Reservoir from Mr. Muhammad Nur Ali Akbar for 60 minutes. And then the second session, we will be having a discussion about the topic from what we have learned before on the first meeting for 30 minutes. And there are some rules that participants should do. The first one is the speaker will explain all the materials in English, but for Q&A session, the participants can use Indonesian or English to ask the speaker. Number 2, participants must speak or chat politely when the event takes place. The participants will be mute and disabled to chat by host during the activity. If you want to ask about the technical or ask questions outside the Q&A session, you can chat to technical_Iqbal or technical_Gilang. And number 4, participants are prohibited to spam chat during the event. Number 5, participants are required to use a Zoom username with a real name, not a nickname. Number 6, participants are required to turn off the video and make sure you are mute during the speaker's explanation. Number 7, for participants who want to ask questions, you can only ask in the Q&A session. You can click and raise hand feature first. Then the MC will give you a permission to speak and ask your question directly. Number 8, the participants who want to ask questions via chat, you should use this format: name, company, or institution, _questions, and send it to me. Number 9, the participants are encouraged to use a background Zoom during the meeting. But if the participants cannot use the background Zoom during the meeting, or committees are not burdensome, you can download the background in this link. The last one, the participants are required to complete the attendance list provided by the committee after the event is over to get the e-certificate. Notes: for participants who disturb during the activity, the committee will remove them from the Zoom. And before we start our agenda today, it would be better for us to pray first. Pray, begin. Pray, finish. And before we start our lecture, we will hear an opening speech from our President, AAPG Unpad Student Chapter, Mr. Ahmad Yuski. Mr. Ahmad Yuski, the time is yours.
Okay, thank you, Ainun, for the opportunity. Can you hear my voice clearly, Ainun? Hello? Ainun, I'm sorry, can you hear my voice clearly?
Yes.
Okay. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. To our Honorable Mr. Muhammad Nur Ali Akbar as the speaker for today's event, and to our Honorable invited guests from alumni and lecturers. Good evening, ladies and gentlemen. Let me introduce myself. My name is Ahmad Yuski Maulana, and I'm speaking here as the President of AAPG Unpad Student Chapter 2020. and it is such an honor for me to speak on behalf of the organizer. Thank you to each and every one of you for gathered back here virtually to keep following the next series of events from TRAPSPOT 2020 at this peaceful evening. Let me begin by giving my sincere appreciation to the TRAPSPOT committee, to the project officer, my brother Benedictus Beryl, and his team for their best work ethic and consistency to execute this event. Before we get any further, I want to express my biggest gratitude to Mr. Muhammad Nur Ali Akbar for willingly sharing some of the knowledge to us. In today's second main event of TRAPSPOT 2020 Online Continually Course with the topic of Introduction to Petrophysical Analysis for Unconventional Shale Reservoir, we will deepen our understanding of unconventional shale, focusing in the petrophysical aspect. Since almost a century, logging has been the key to unlock the reservoir potential in the oil and gas industry and the road towards the new discoveries all over the world. Petrophysics is considered as the core of the subsurface evaluation from the new ventures through to mature reservoirs. A method that has been proven effective in conventional petroleum system is something that we must also possess when we talk about unconventional systems. With years of Mr. Muhammad Nur Ali Akbar experience in this industry, I want to assure you all that our discussion this evening will be guided by the expert itself. So to all the participants, gather as many information as possible, and may we get the greatest benefits from today's event. I think that's all from me. Enjoy the event. Thank you. Wassalamualaikum warahmatullahi wabarakatuh. Back to you, Ainun.
Thank you to Mr. Ahmad Yuski for your welcoming speech. And then before we are going to the main agenda, I will read the CV first from Mr. Muhammad Nur Ali Akbar as a keynote speaker for today's activity. Mr. Muhammad Nur Ali Akbar is a petroleum engineer and researcher based in Indonesia and Hungary with over 6 years technical and consultancy experience in the field of reservoir engineering and petrophysics, with additional competence in rock physics and machine learning development. Obtain various international achievements and having abilities to work both independently and teamwork with a good leadership skill. Here is the latest experience from Mr. Muhammad Nur Ali Akbar during the past year. He worked as a reservoir engineer and petrophysics for building and simulating the reservoir dynamic model. He evaluated, analyzed, and interpreting the petrophysical properties through well logging core data, transaction, RCA, and SCAL. Proficiency in the plan of development, reserve certification under SKK Migas and PRMS standards. Mr. Muhammad Ali Akbar, from September 2019 until January 2020, he had a project for studies provision of gas reserve certification in fractured basement reservoir at Sakakemang field operated by Repsol. And from November 2019 until February 2020, he had another project for study provision of gas reserve certification in carbonate reservoir, South Biru field operated by Ophir. And in November 2019 until February 2020 again, he had another project for water flooding study of Karst reservoir in Bukit Tua field operated by Petronas. And from March 2020 until August 2020, he works as subsurface grower at MOL Group, Budapest, Hungary. And from August 2020 until now, he works as petroleum engineer at MOL Group, Budapest, Hungary. Now we are going to straight to our main event. The first session is going to start now. We will learn about Introduction to Petrophysical Analysis for Unconventional Shale Reservoir Shale. To Mr. Muhammad Nur Ali Akbar, the time is yours.
Okay, thanks Ainun. Thanks Yuski for opening the conference. Let me start to share my screen. Can you see my screen, guys?
Yes.
Okay, cool. So I would like to do it in the slideshow. Okay. Oh, what is it? It's, a moment. Did you see my screen clearly? Because I saw there is something distraction into the.
Oh.
or how I can remove this. Moment. Okay. Okay, I will start. So, good afternoon. Oh no, in Indonesia it's good evening, everybody. It's a bit honor for me to stay here for giving to share some informations or some knowledge regarding my experience in the petrophysical analysis concerned with the unconventional shale reservoir. Before I'm starting my presentation, let me introduce myself. It was introduced by Ainun. Thanks a lot. But let me introduce from my side directly. So my name is Muhammad Nur Ali Akbar. You can call me Akbar. It's quite common. The people call me Akbar, but some people also call me Ali. Now I'm working as a petroleum engineer in MOL Hungary, focus on the naturally fracture reservoir characterization for both petrophysics and reservoir engineer in mainly. But also I'm involved in several kind of the unconventional projects such as shale oil, and also for the mercury investigation in some reservoir, in tight reservoir as well. Not only working with the subsurface, I also involved in the surface problems, let's say like a surface facilities and some production optimizations. So I think it was already mentioned by Ainun. I don't have to pay a lot that I was my study background was petroleum engineering as a bachelor's, and also I continued my master's in the last 3 years. It was in the University of Miskolc, as petroleum geoscience and engineering. So at least I learned the view not only about engineering point of view, but also with the geoscience. I also really active in publications. At this moment, I publish is more than 20 papers. You also can discuss with me if you have some idea about research, try to collaborate with me. I'm so happy to discuss about this. Don't hesitate to contact me by emails or by LinkedIn. And in the last 2 years, I also participated in many competitions. My latest competition was in the SPATCE. It was held in Canada. I won the second runner-up at that time, which is the third place. And also in the 2019 as well last year in Poland, in Krakow, I also won the first place student paper contest for Europe region. So that's why I was represent the European region last year for the World Championship. I also received some of the award as well relating with my papers. It was the best article last year in Hungary, this year in Hungary, and also last year was chosen one of the best geoscientists. So I really have a big focus of research in petrophysics, reservoir characterizations, integrated study. So whenever you have questions or any interest in research, you can in touch with me when we will discuss further. So for the presentation today, it will be the outline for today. I divided into 3 main sections: introductions, analysis, and methods, and summary. For the introduction, this will be talking about the overview about the reservoir, conventional and unconventional in the nutshell point of view. And after that, I will continue with the basic petrophysics, and then conventional and unconventional reservoir comparisons, basic unconventional petrophysics, petrophysical model and properties. And later, we will more detail how to solve the problem, how to work on it. Let's say we will start with the basic method in petrophysics that we usually use and compare with the unconventional. We also try to explain how we estimate the TOC or total organic content in the search of the cell sediments with the brittleness index. The last but not least is sweet spot intervals. This is also one of the important parameters. I mean, the summation that we will reach in the petrophysical evaluation, and it will be closed with summary. Okay, unconventional. We can say my source rock is now my reservoir. Yeah, it's happened. So whenever we are talking about conventional reservoirs, it's quite common that at this moment, especially in Indonesia, the productions is all of them is coming from the conventional gas or oil, which is this conventional gas and oil. A moment, let me try to in the lesser point. So this kind of the hydrocarbon is coming from the migration which is taken from the organic rich shale, or we call it the source rock itself. Whenever the maturation is reached, you have a quite content of the organic, the hydrocarbon will try to migrating into the trap section, which is in the reservoir. And this is, I think you already learned as well in the geological point of view about the petroleum migration or petroleum system. Another one, we have some unconventional reservoir. We call it CBM, coal bed methane, or coal seam methane, another information. And I was also involved when I was doing my internship in 2013 in FICO, Indonesia. It was in East Kalimantan. But unfortunately, the resources of the coal bed methane at that time was working not really well. So that's why this project, as far as I know, the project of the coal bed methane in Indonesia is suspended. Another one is also take into consideration, we have tight sand oil and tight sand gas. This is also promising because we have a quite expected resources that it could be a good candidate for being developed. But today, I would like to more explaining detail about the oil and gas in the rich organic rich shale, which is we call it the source rock, or in many cases at this moment they call it organic rich shale or organic rich mudstone, which is really huge impact in the oil industry at this moment, especially in the US. Talking about the overview that I show you here, there is a distribution of the resource estimation in the around the world. You can see the brown colors together with the light brown in here. It's show that the estimated resources which distributed around the world. However, we know that the only in US at this moment give really huge impact in the production or in the oil industry. And it's already proved as well the production and field development for the shale gas in the US make a really great impact in the petroleum world. And if you see, there are five five biggest common of the field that are really interesting to be informed to you, that both of gas and the oil is prepared in these five big basins. And not from here, let's see, just compare one of the study case which has happened in North Dakota. The production, it was in 2013, it could be reached around 800 barrels per day. Can you imagine that? This is really huge, only in from this basin. If you compare all of the production in Indonesia, is less than 800,000 barrels, but this one is only from one basin. It could be produced in North Dakota. It's more than our daily production in Indonesia. So that's why if we're compiling all of the production around the America or USA, it's really, really huge. So that's why this kind of behavior was triggered many countries around the world to estimate their or to evaluate their resources about organic rich shale, and they are trying or compete to get this kind of the energy resources that I mentioned previously. In the last 20 years, let's say from 2000 in 2010, the production of the shale gas is not directly like we produce the shale or the shale gas or shale the oil conventional in the conventional system. They are waiting for really high investment and take into consideration for the production performance as well. But after that, during 2010 into 2016, it's really exponentially a significant improvement. So at that time, if you remember, when I was studying in 2010, The production was not really high, but at that time it was the highest oil price. It is around 120 barrel US per day. I was thinking that, oh, we have a very big, we have a really good futures. But unfortunately, in 2012, you see the improvement of production is it's twice bigger than 2010. And at that time, the oil price was really low, from 120 went down into 20 US dollar per barrel. So that's why a lot of people was lost their job because the oil price was really low due to the really high production of the shelf. So that's why we try to see in Indonesia, if we magnifying the Indonesia, the distribution of the assessment of the basin, it's normally we have some basin assessment in the West Papua, in the East Borneo or East Kalimantan, and in the Sumatra Island. From the west, east, and from north, south, and the central Sumatra. But at this moment, the latest study, it was studied in 2017. There was a well was drilled in the North Sumatra Basin, and it was dedicated for doing the exploration in the shale gas. And I was also involved for this investigation as a petrophysicist. So this is the latest study that I was found from Mas Bahesti, which presented yesterday. I read his paper and also combined with the Junita Musu paper in 2015. If you can see that just in the North Sumatra basins, there is expected resources around 3.5 trillion cubic feet. Meanwhile, for the oil is around 200 or almost 300 million barrel. It's quite huge, but this is still resource. It's never been proved. And from the previous investigation, also from the SKK Migas report, there was mentioned that our shale gas potential is around 500 trillion cubic feet. It's really huge as well. But however, it's never proved. So what we need in the future is proof that we have this kind of the resource in our subsurface. But today we are not talking much detail about the general thing, but we are looking for details. What is the important in the petrophysical point of view regarding with the richness of the shale or the quality of the shale that we can develop for being an unconventional reservoir. Let's start with the basic petrophysics. Because I know that from the committee that the participant is not coming from the petroleum engineering, but most of them is coming from geological science or geological engineering. So that one, we have to consider that not all of the students or a participant here is studying petrophysics. So let's say I'm starting with this beautiful pictures from the Calgary Health Cartoon. I took it from the Crane Petrophysical Handbook. And actually, how do we know beneath the surface, 2 kilometers, 3 kilometers under the surface, how do we know that inside the rocks, inside this earth, that there is a hydrocarbon there? So that's why it's not like we are thinking from the small hole, which is called well, we can directly identify trillion cubic feet, 2 trillion, 3 trillion, 100 trillion. It's not simple as that thing. So we are not the God, we are not angels that we can go into through the subsurface. But from the information that we obtain from the well, there are some questions that always be considered. First, where are the hydrocarbons? The second, how much volume is present? How much of the volume can be produced? What rates can be produced? And what are the uncertainty? How many percent we will fail? How many percent we will be success? So what should we do? First of all, we have to go inside, diving into the borehole, but it's not us just coming into the borehole, but we run the tools, which could be electrical tools, nuclear tools, sonic tools, acoustic tools, and so on. But at least we will find many kind of information from the physical measurements. And what kind of the physical measurement that you usually use that I mentioned previously, in the long time ago, the people normally use the electrical. system, which is resistivity and SP law. But during the time, the technology is well developed, the radioactivity is came, and then it's followed by the acoustic. And at this moment, we have a quite good technology. They call it nuclear magnetic resonance. And this technology was initiated using the medical measurements, but now it's also obtained for the oil and gas investigation tools. Not only about the difference of the tools, we also, as a petrophysics, work with the different scale. It's starting from the kilometers, 100 meters, until the smallest one, which is nanometers or micrometer. And what we want to find, it's simple. We are going to find the porosity of the rocks, the permeability, grain density, oil saturation, and so on. And from this one, we need the integration every single data from the seismic, borehole seismic, from the well logs data, core data, and some of the petrographical analysis, let's say from the scanning electron micrographs. And also, the petrophysics is not only talking about log analysis, but it is integrated from the very kind of the data that we have to consider, that we want to identification and quantification of the hydrocarbon resource in the subsurface. Another one, we try to evaluate of the nature of the formation fluid, the rock properties, and also the interaction between the solid and the fluid itself. The main source of the information of the petrophysics that I mentioned previously, at least we have the data from the logs, but also it's supported with the another data, let's say like mite log data and the cutting. Sometimes we also need the cores from the whole cores or from the sidewall cores. Another one, from the log itself, we have several kind of the measurements. We have the measure while drilling, or logging while drilling, or formation evaluation while drilling, or wireless logging. One of the important data as well is pressures, fluid sampling, the gradient, that it will be help us to identify some of the petrophysical properties. And from this data, as a petrophysicist, we will do the integrated study in order to define the saturation, porosity, permeability, grain density, lithology, and so on. This is also the same that I mentioned previously. From many kind of the data, we do the combination, what it's used for. Actually, the data that we are taken from the logs and from petrophysical analysis. It will be really useful for the petrovolumetrical calculation, dynamic reservoir simulation, and static models. So we are going to the unconventional now. So we have two kind of the reservoir at this moment, conventional and unconventional. But unconventional at this moment, I will speak about the shale oil or shale gas. That if we compare that in conventional, the oil and the gas itself from the source rock is already migrated to the carrier bed, and it will be stopped in the trap system. This is the common reservoir that we have. But in unconventional, the gas or oil is still remaining in the source rock. They are not migrated. So that's why when they are trying to trap in their source rock itself, it is a really good potential that we can drill there, we can absorb there, or we can produce from these intervals. The second one, the secondary cracking of oil to gas in reservoir is not really important in terms of the gas, shale gas. But for the unconventional, this is really important because it will be relating with the maturation of the rocks, and the secondary cracking is one of the key that we can identify that our source rock is in the oil window or in the gas window. The third one is porosity is modeled in reservoir. For the conventional is just intergranular or the free or matrix porosity. But in unconventional, the kerogen or the organic content itself, it should be take into consideration for the porosity, because some of the porosity in kerogen will be evoluted into the pores that I will explain in detail in the couple slide. The last but not least is about water saturations or the fluid saturation. In the conventional, we model the free gas in the reservoir is only from the free gas. But for the unconventional, the not only free gas, we also have to take into consideration the absorptions parameter or absorption saturations for the organic content. So in the simple way, if you see the conventional, it's really beautiful, easy to identify that we need. In the one of the bulk of the rocks, it will be content of the matrix and also the shell itself. But what we want to focus in the conventional is the effective porosity, which is in the effective porosity, it will be occupied water, irreducible water, initial waters, together with the oil and gas, which is occupied in the pore system. And this is, we call it the reservoir in the conventional. But in unconventional, it's quite confusing because we have the solid part and we have the pores part. Inside the pores, we have four main of the porosity. The porosity of the free shell porosity. We have an effective porosity, which is the same with the conventional here. But inside the shell, there are some free shell porosity, which is without clay. Or we also have a clay porosity, which is dominantly with the capillary bond and clay bond water. And we also have organic content. And in this organic content, dominantly with the adsorbed hydrocarbon in both oil or gas. But the waters, it still be a questionable until now. Do we have waters inside the kerogen or not? And that we will discuss today and try to develop our idea that it will be good for the future research. So if we are dealing with the unconventional reservoir, we are talking about the pores which are created inside the kerogens. And you can see I make a shading here. So the organic pores is really small. It's really like a virus. Can you imagine? Can you see the virus? It's almost impossible to see the virus even by using a microscope. At least we need the scanning electron micrograph to identify the virus, maybe. But at this moment, some of the investigation, if we compare with the molecules of the fluids, let's say the fluids which dominantly contain in organic pores, it's relating with the asphaltene, paraffin, and some of the complex ring structure from the hydrocarbon and naphthenic acid as well. So that's why whenever the maturation is created, the evolution of kerogen into the maturation system, sometimes we easily to find the quite high content of the asphaltene, and this is one of the key as well to identify the maturation of the source rock. Another one, if we compare our conventional reservoirs, it could be around microns of the pore size. So it's much bigger than bacteria. So that's why it should be taken into consideration that if we only use the conventional log to identify this kind of organic matter, is it possible or not? This is also the questions, not only for me, but it's also a good question for you to think about it. So that's why if we see the basic log responses normally in organic rich shale, it's quite challenging because in many cases of the conventional reservoir identifications, we always try to find the low gamma ray. Low gamma ray, high resistivity, low density, high neutron, and it will be crossover. This is the best way to identify, right? But in unconventional, I said it's impossible to see this kind of behaviors. So first of all, we are looking for the high gamma ray. High gamma ray is because of the high TOC content, which is dominantly high with the uranium and the phosphate as well. Another one, the kerogen affecting the decreasing of the density as well, because the kerogen density is normally is less than it could be twice less than the quartz density, which is sandstone or dolomite around 2.7, but this density is around 1.3 to 1.5 gram per cc. So that's why there will be impacts on the density. It depends on the TOC content that we have in our shell. The third one, the neutron. The neutron, it will be relating driving with the clay. With the expandable, the clay, it's make the porosity unit from the neutron is quite high as well from the measurements. And sometimes, yeah, we can see the neutron density crossover in the good quality gas shell, but it's not always that you can find this kind of behaviors. Another one, we have sonic lock as well, because the basis is the velocity. Sonic lock is normally in the travel time. Whenever we find the presence of the organic matters, we will quietly have quite higher delta T or lower velocity. Another one, resistivity. We know that in the organic matters or in the hydrocarbons, the electrical is cannot the current of electric is cannot penetrated. So that's why normally we have higher resistivity if we find quite a high of the TOC. Another one, SP, I don't think so. We can see anything from the SP. It's quite difficult to see. But for the PEF or photoelectric factors, we still can see some of the organic rich shell with a really low PE or photoelectric value. Another one, we also need the basic log alone. So we need some an additional measurements even in the well log or in the course. I can say here that 3 additional log, it is also good maybe. This is not from my recommendation, but it was recommendation by Glorioso in 2012 that nuclear magnetic resonance or NMR logs, it also can be helpful to identify the kerogen measurements, because from their research, the porosity from the NMR is only can identify the free pores, which is the free fluid force distributions, and they are comparing with the porosity total from the density, and they believe that this kind of the difference between this density porosity with the NMR porosity, this is the effect of the kerogen, and this is in the pore volume section, and then you can convert it into the weight % of the TOC. Another one, we also need additional lab measurement. As a petrophysicist, we need the TOC measurement result, which is normally measured from the rock eval pyrolysis, or there's another one, they call it LECO, L-E-C-O. Both of this measurement is actually producing the TOC contents. This TOC contents will be considered as well later for calculating the porosity and water saturations. Another one, we need XRD and XRF, X-ray fluorescence, X-ray diffractions. It's relating with the mineral compositions and the chemical elemental compositions in kind of in the given rocks. We also need some Langmuir adsorption desorption isotherm test in order to define how much the gas it could be adsorbed in 1 ton of the solid of the rocks, and it will be related with the pressure that is given, and also it's also related with the temperature as well. We have a micro CT scan. This is also important to see some of the interconnected natural fracture that we can see from the cores without crashing or damaging the rock itself. We also can use some core NMR. Maybe it will be useful as well for calibrating the NMR from the log as well. But another one, we can identify the pore size distribution without using the mercury injection capillary pressures. The other one is rock mechanic test. We are testing how much brittle of the rock, how much easy the rock can be fracked or could be to break these rocks. This is also really important for the hydraulic fracturing purposes. So let's start with the TOC. I think the geological student is really well recognized about the total organic contents. Normally, it's related with the kerogen, and we have some several kerogen types. Let's say we have 4 kerogen types in here: kerogen type 1, 2, 3, and 4. Kerogen type 1 is normally from the terrestrial sediments environment, just like lacustrine or maybe pluvial as well from the type 2. But for the type 3 is dominantly for the coming from the marine environment. And this kind of kerogen is also be a good key for us to know our reservoir is a shale a gas or a shale oil. And it's offshore. Of course, it will be related with the maturation as well. And these maturations and together the TOC from the TSOT and well in 1961 and passed in 2010, they said the good shale gas, at least they have the TOC is around 1%. But the rule of thumb so far that I understood, at least you have 2% of the TOC. It will be really good. But not only the the organic richness, but also we have to focus as well with the thermal maturations, which is relating. We are in the oil window, in the gas window, or it's already over mature. So that's why this consideration, it will be really important for our further investigation for petrophysical point of view. So this is the pore system in unconventional that I can show you. This is from the papers in SPE 153004. Normally, if we have the one rock book, if you have one rock book, it will be contain pores and the matrix, which is the solid itself. And inside the solid matrix itself, we will have the dry clay and non-clay matrix plus kerogen. The non-clay matrix, it could be the quartz, it could be the marl, it could be the carbonate, calcite, or dolomite, or another mineralogy. And from here, from the porosity itself, it will be divided into several kind of porosity. If we see from the conventional point of view with the standard logs, from this porosity, it will be divided 3 porosity: total porosity, effective porosity, and a porosity shell. And the effective porosity in the conventional is the total porosity minus the porosity shell. However, if we run the NMR logs, we can identify the free fluid, the total bulk volume, fluid volume, which is this is bulk water. But inside this bulk water, it's divided again into two saturation, which is the clay bone water and the capillary bone water. And if you're dealing with the shale gas, from the PASI models, the PASI doesn't considering the organic matters is with the porosity in these models, but only the effective pores from this cut, and for the shale matrix, it could be ignored. But however, if we see from this is the conventional intergranular pores, when we do the magnifying in here inside the corrugans, let's say in the 500 nanometers or half of the micron, we can see how was there are also pores will be created in some of the organic. And we have to take into considerations because this could impact in our storage calculations, and also regarding with the porosity and also with the water saturations. So that's why I can tell you inside the matrix itself, we have two kind of the system, which is the kerogen system or organic system, and in organic system. In organic, we have the clay mineral and non-clay mineral that I mentioned previously. And from here, we have the porosity from free fluid, and we have the porosity clay, capillary bone water and the clay bone waters. But the most important one is the free porosity is available together with the kerogen, which is adsorbed gas, and the free gas as well, which located inside the pores of the kerogen itself. So if we make the illustration, the distribution of the gas in the, let's say in the gas shell, it's not only distributed in the pores space of the free porosity, but also in the surface of the grain as well. It's quite huge content of a gas particle, which is it should be take into considerations for the calculation of the in place of the gas or in place of the oils. If we also try to see in the other point of view, if we are dealing with the conventional reservoir, we will have a higher pore size. Whenever you have higher pore size, the specific surface ratio with the volume, it will be quite low. It means that your free gas, it will be higher than adsorbed. Meanwhile, the smaller of the pore size you have, the smaller as well from the grain size you have, you will have quite higher of the specific surface to volume. And then it could mention that our adsorbed gas is it's much higher comparing with the free gas. So if we're dealing with the shale, don't think that our free gas is could be high, but what we expected that our adsorbed gas or adsorbed oil, it is the highest value that we have take into considerations. So that's why when you do the water saturation estimation, it's really high water saturation. It's not mean that this is coming calculated as well from the adsorbed system. So that's why this is should be incorporated when you are doing the calculation. And also it should be taken into to account that weight percent from the TOC measurement, which is from the lab, it's normally from the weight persons. And you have to convert it to the volume persons, because if you have one bulk rocks, and inside this one bulk rock, it's contain around 5% weight percents of the TOC, because we know that the organic density, it's half of the rock mineral density normally. So it's meant that if we are converting to the volume, the volume percents of the TOC itself in the rock bulk is around 10%. And you know, it is in the current situation, at the present situation, because in the mature organic shale or in the source rock, we can assume, let's say 50% of the organic is already matured. So it's mean that there are 20% of the pore volume at that time when the rock was formed, and the 10% was already evoluted or already evoluted into the free hydrocarbon, which is gas and oil, and they are migrated or still remain in the free porosity. But half of it, which is 10%, is still remaining. And by the time this will be reducing the TOC, it's mean that the porosity will be increased. We don't know how many years. In the geological time, it could be 100, thousands, 100,000, or even million years in the next future. So that's why if you are dealing with the shale gas, our production is quite low, but it's really sustained. You can get the production one wells of the shale gas maybe could be more than 50 years. Meanwhile, in the conventional reservoirs, we can produce maybe just 5 years, 10 years, and it's already died. So this is also should be taken into account for the future investigation, especially for the shale gas evaluations. Another one for the fluid saturation and unconventional gas. There was a study from the Xu et al. In 2017, and from the PASI in 2010, they make the illustrations that saturation in organic rich shale have been using the method for the conventional and shale dry gas. And you know, this method is not working actually for concerning the sorbate organic matters for the oil and the gas. And from the study, we have to consider that SW, it should be considered not only SW from the conventional, which is only from the free saturations, but also the water saturation in the organic contents. In many case study, let's say from the Feiyu et al. In 2013, if we have this kind of porosity from the petrographical analysis, they do some image analysis, and they can see that the porosity inside the kerogen could be up 25.6%, with the pore volume or pore size is around 12 to 380 nanometers. The diameter of the pores is really extremely low. But if it's quite height of the TOC, it will be give the good impact as well. How much the potential of the storage that we can have in the unconventional reservoir, and also some of the measurement as well in the laboratory. If we are dealing with the conventional with the orange colors, we have the pore system. Normally, our pore system will be occupied with the water or irreducible water saturation. And also with the hydrocarbon. When we do the cleaning in the laboratory, when we take the sample, it should be clean, right? Before we do some measurements. If we clean in the conventional reservoir, the porosity will be the same what the porous was remaining in the reservoir. But in many cases, in the shell, when you do in the organic content, you try to cleaning the organic content, which is the oil and gas inside the pores of the organic content. Some of the kerogen itself, it will be clean. So that's why the pores will be estimated as quite more optimistic, and it should be as well to be attention. So if we go to the fluid saturation in unconventional shell, especially for the porosity in the organic shell, which is low maturity or immature. So it's mean that the kerogen is not changing yet. The kerogen is still in the solid. So that's why the water saturations, it could be up to 100% water saturation at this moment because of the clay-borne waters. We don't have a free hydrocarbon at this moment, but the SW in the organic, it's totally it's a totally full of the organic hydrocarbon, but it's still solid, which is immobile. If we go to the maturation system, let's say in the oil window, the oil is already generated from the source rock. Whenever the oil is generated, some of the oil from this kerogen, it will be expelled, and they are trying to migrating in the free porosity. And now you can see that in some pre of the porosity in here, it's already occupied by the hydrocarbon, which is the oil. And from here, we can say that the SW conventional, it could be less than 100% for the free hydrocarbons. And after that, for the organic content as well, it's already less. Some of them is occupied by oil, or even the gas, but the solid still remaining there. If you are dealing with the gas window, which is the RO is more than 1.1, and you also can see the gas and the oil will mix in the free saturations, and some of part it's still absorbed in the surface of the kerogens, and some of the kerogen as well is still remaining. So that's why the water saturation or the porosity as well from the kerogen itself together with the free gas, it should be considered. So in overall, what we need to do the investigation, first, we have to define the organic content and the quality, including the richness and the maturity. Not only you have a quite rich or quite high intensity of the TOC, but also the maturity, it will be also the important key of the organic shale. The second one, after we know this kind of parameters, we can do the calculation for the storage capacity system. It's including porosity and hydrocarbon saturations. After that, we evaluate the flow ability system, which is the network fracture networks, and also some pneumatic permeability is possible. Another one, this is one also important, that the shell, it should have the ability to be fracked, which is mean that we need the hydraulic fracturing in the future, then the petrophysicist has the tech responsible to identify the quality of the rock. It's has a good brittleness or not. Whenever we have these four important items, then we can evaluate the organic rich shell through the petrophysical analysis. When what we need is also integrate the laboratory measurement from the TOC, porosity, water saturations, the fractures, and also from the brittleness index. mainly we need the petrophysical and geochemical data, and also it's supported with geomechanical. And finally, we can define the pay zone, or we call it in the organic shell, the name is a sweet spot. So this is the workflow that we need to do before we proposing the value for the for calculating the original gas in place or original oil in place. Is written by Bass in 2013 papers. So what we need is a TOC. The TOC measurement is could be measured from the estimated from the gamma ray uranium or the density, and make the log-based relationship based on the core data, and finally we get the TOC. Or another one, we also can identify from the NMR density, NMR and density log, sorry, that I mentioned previously. We also can do the mineral composition log analysis, let's say kind of the lithology scanning measurements. And also there are a quite common method from PASI in 1990s. They call it delta log R, and from here also can produce the TOC. Whenever this method is already run, they are validating each other from the core, from the cuttings, and then you have the TOC data. And after that, what you need, you have to identify the adsorbed gas saturations from the organic contents. And it should be do some measurement in the laboratory, and it will be related later how about the relation between TOC and absorbed gas, and we can identify how many standard cubic feet per ton of the solid rocks or from the bulk rocks. Another test also in the lab, they call it Langmuir isotherm, and this is also should be taken into consideration to calculate the adsorbed gas saturations. Another one, we calculated the porosity. The porosities could be many kind of the log measurements from the bulk density, from NMR, from the compositional logs, considering which is a multi-mineral analysis from the well log inversion. Another one, we have also considered the bulk density, especially for the clay mineral volume as well. And after that, we calculate the water saturations, and finally, we can do the calculation for gas in place. And after that, this is also another workflow. It was written by PASI. The workflow of this calculation is practically is the same what I presented previously. So what you need from here, we need the TOC, we need the maturations. Whenever we know the TOC and maturations, we will consider to calculate the total porosity, the water saturations, and also additional geochemical parameter, let's say the fluid inclusions to the wetness and API gravity. This is also really important. This absorbed gas volume was measured in the laboratory for unconventional. We have one laboratory consists of this measurement. It was in Lamigas, and it was used as well when we were doing the evaluation of CBM or coal bed methane. Another one, the free gas permeability microscopy, like from the SAM, from the focus long beam from the SAM to see the composition, and also from the thin section is also important. And the geomechanical properties, this is really recommended to be implemented. Let's see from the basic petrophysics. We have, before we go really detailed with the TOC, porosity, water saturation, let's see your compositions. If we compare the most common of the reservoir unconventional in the US, it's at least, and also in Argentina, at least the clay, it should be less than 50%. Why? Because the clay is the poisons. What is the main the poisons? It's make the rock is less brittle. The seconds, the permeability is extremely low, and so that's why try to identify the shell not only high organic rich shell, but also consider the clay. It should be should be minimal. If we see one of the case study in the North Sumatra basins, we have two kind of interests. It is lower bong and the blue mine formations, and it you can see that in lower bound, there are some interval of the core sample, the clay is quite high. So that's why it's quite dangerous for us if we do some defining the shell from this kind of soil. But we need that at least we have really low clay content, which can be shown in the blue formations. Is quite high of the carbonate and quartz, and it will be good. But however, when we try to see our clay is dominated with the kaolinite elite, which is it's quite brittle, but I'm not really recommend as well whenever we have clay is more than 50%, whatever the clay. But for the kaolinite maybe it's okay, but for the elite or smectite or chloride, it's really make the poisons for our unconventional shell. What we need to calculate the TOC, there are several methods but I just want to show you 5 important methods that usually used in the oil industry. First of all, we have the easy relationship between Robbie or book density log with the core TOC. And from here, you can see the study from the smoker in 1987. The relationship between the total organic carbon versus the bulk density is quite really consistent. So that's why this relationship is the easiest way to define the TOC. Another one, we also can define from the PASI method, which is delta log R, which is based on the separation between the porosity logs, normally sonic logs, and the resistivity log, do the overlay and define the wet clay bridge shell. And after that, you will see any kind of separations initiating the hydrocarbon or the kerogen contained in the rocks. But the problem is sometimes we need the local knowledge of correction about LOM, which is level of maturity. Normally we can use the rule of thumb 10.5, but it's a quite high uncertainty. You need to know the information from the geochemical analysis about that. You also can calculate the TOC from the capture gamma ray spectroscopy, which is the carbon from the epithermal neutron capture spectrum minus the inorganic carbon. And from that one, we will know that the organic carbon from this measurement. This kind of the method was also used for the LECO measurement in the laboratory. From LECO, LECO that I mentioned previously, they try to calculate the total carbon with the minus in organic carbon, and they will find the organic carbon itself. Another one, multi-mineral analysis, well-log inversion basis, with supported with the XRD data. It's also really recommended as well. And also the difference between NMR log with the Robbie, it's also quite useful. And then all of this method, you also can try to compare each other to understand the TOC or the total organic carbon content in the rock itself. What I did to calculate the TOC, you can see in here, I have the TOC calculated from the PASI based on the delta log R. I have the modified carbolog methods from the multilinear regressions, and the other one is linear regression from the smoker method, which is the very simple way. This is the density of the versus the TOC at that time that I calculated, and you can see the distribution of the density TOC. It's shown in the from this one, from the orange line. It's quite really good TOC comparing with the coarse and the cuttings data. And we also calculated from the PASI. From the PASI as well, it's quite interesting, but from the carbolog, it's quite challenging to see any kind of behaviors. So that's why at that time when I try to evaluate the TOC at this moment, I do the averaging between the TOC from the density and also from the PASI, and the average of this one I use for my final model. And after that, we calculated the porosity. Calculating the porosity, normally you use this equation without considering the TOC. This is the total porosity that we usually calculated. However, for the metric density, it's really recommend us to use the multi-mineral analysis, and the grain density from the multi-mineral analysis, it should be taken into consideration to calculate the porosity, but also the organic content in the weight percent of the TOC, it should be calculated as well in order to define the porosity considering the organic. And you can see from my investigation in 2018, if you see the blue colors line together with the brown line, it's there will be there was some of the difference which is shaded in the yellow colors. So this blue is the total porosity from these calculations, and the brown porosity it's calculated from the normal measurements from the effective porosity measurements. So that's why we can still considering that these yellow colors is a difference of the organic porosity that we have to take into consideration on it. And from here that I can mention you this shaded yellow, this is the absorbed gas that we can identify from these rocks. Another one for water saturations, there are several methods to be calculated in water saturations. There are some methods from the SU in 2017. It's quite new in the last 3 years. We had NMR log data from the T2. We will see the clay-borne waters and the free water saturations, and we will considering as well with the conventional saturations. Some of the log also was recommended, but I never used this one. It was written in some of the literature, which is the electric dispersion scanner. Another one, multi-mineral analysis, also could be taken into considerations with the control of the water saturation was supposed using the modified Simandu. However, you can also use the other water saturation method. Another one, modified Indonesian best total porosity as well. It should be taken into considerations, but this total porosity, it should be using the total porosity that I mentioned in the previous slide by using this total porosity that considering with the TOC already. So this is one of the examples from the SUD in 2017. If you have the water saturations from the conventional RC method, and you have the red colors in here, this water saturation was considering based on the organic in the lab measurements. You see the difference. Meanwhile, if you do the method based on the SU that I will explain in the next slide, you will get the more reliable water saturations to be considered in this system. Let's say in the SU et al. In 2017, it was the study in Sichuan Basin, Loxi-Wufeng Formation. Long-Maxi-Wufeng Formation. The water saturation, it's divided into two models, which is water saturation separation model or water saturation TSC methods. This kind of equation actually give almost similar results because it was generated from the relation between the TOC over the water saturation conventional and from the core. So that's why if we comparing with this one, they have the rule of thumb, it's 1 A and B is 1. With this conventional water saturation with the TOC, we will define the result of the water saturation. And you can see between the SW-TOC method is from this method, from this SW different from this method, and they're almost the same results. They also, you can, I think this method also can be good consideration when you are calculating the water saturations. This is my study in 2018 by using the modified Indonesia with the total porosity considering the organic content. I compare with the SU et al. 2017 methods, and you can see the black colors and the blue color is almost the similar results. Meanwhile, if you only using the basic water saturation method, which is Indonesia or modified Indonesia or even the RG, your water saturation will be really high. It's mean that there is no gas or hydrocarbon is occupying in the free system. But meanwhile, when you are dealing with the organic considerations, your water saturation could be much lesser comparing with the conventional one. I think we don't have a long time. We only have 2 minutes left, right? So what I will suppose, the last one is the brittleness index. This brittleness index also could be identified based on the log, which is from the acoustic logs. We can calculate it from P wave velocity and shear wave velocity to calculate Young modulus and the Poisson ratio. And from here, we can calculate the brittleness and do the normalizations. And finally, we can calculate the brittleness index based on this brittleness from the Young modulus and Poisson ratio and divided over of 2, which is the average of it. And later on, we can also compare the brittleness index from the mineralogy analysis, let's say from the XRD. We have the quartz, we have dolomite, divided with quartz, calcite, TOC, clay, and dolomite. And this method was named is the Wang and Gale brittleness index. What I did at that time, I tried to compare it, the brittleness index from the logs based on the line and the cores, or from the XRD measurement is coming from this point or dots. And it's quite really good to see the behaviors. But what we need to identify the brittleness index, at least we can make the brittleness index with the cutoff is around 50%. If we have the brittleness more than 50%, it's mean that our rock it's available to be fracked, or we can conduct the hydraulic fracturing activity on in that reservoir. So this is that I mentioned previously for the sweet spot. Just give me 2 minutes. From that I mentioned, TOC or organic richness, storage capacity, flowability, and brittleness index is the main key for defining the sweet spot. And the sweet spot as well, it's a meaning of the target locations or area within the play or the reservoir that represent the best production of potential, or maybe in a conventional, we call it as a pay zone. And from here, we have also the cutoff. The cutoff is not only porosity, water saturation, and visual, but our cutoff now is about our TOC, because the TOC will be regarding with the adsorbed gas analysis as well. The more organic we have, the more adsorbed gas it could be potential. It has a possibility to adsorb the gas. Another one, we have also considering the gas maturity. What we focus with the shale gas, the gas maturity, the maturity of the source rock, it should be in the top of the gas maturity depth. Meanwhile, for the shale oil, we are focused with the top of the gas maturity and the top of the oil maturity as well. For the storage capacity, we also considering not only the free porosity, but also considering with the matrix and the adsorbed gas. And then also for the water saturation, we have to consider free hydrocarbon, the adsorbed hydrocarbon, and the bone water as well. We also have a flowability system. We can see from the image log. We can also identify from our core sample to understand the naturally fracture distributions. And lastly, it's the most important one as well, which is the brittleness of the rocks. Some of the recommendation, it could be more than 60%, but some of the paper as well, they said 50% is enough to have a brittleness. But the good thing is that the more brittle is the better quality of our reservoir to be break or to be fracked. So in the summary, yes, of course, we can say that shale is highly heterogeneous, vertically and laterally. It's quite challenging to identify based on the core and the logs, but we have to incorporate any kind of the data that we have from the laboratory, from the different disciplines, from geoscientists, from geologists, from geophysicists, from geochemistries, from geomechanics, and so on, and also from the engineer as well. That we know as well, the laboratory measurement are strongly recommended for the unconventional shale reservoir. And from here, it's because without this, it's really difficult for us to calculating the organic matters by using the conventional log. And also, core to log relationship study are also really recommended. Whenever we get the good relations, it will be easy for us to identify it. Also, the multiple source that I mentioned previously is really good in order to reduce the uncertainty. And lastly, before I close the presentation, the reservoir pay is not only about the reservoir quality, but also it should be combined with the completion quality in order to develop the shale plays to get the success shale play identifications. So my closing word, the best petrophysical interpretation way is always back to basics, understanding the physical principle of the measurement instruments, and well recognizing the body physics of the rocks and the fluid. That's all from me. Terima kasih. Thank you very much for your attention. I give it back to Ainun as a moderator.
Okay, thank you, Mr. Akbar, for the amazing lecture. That was the end of the first session. Now let's continue to our next session, Q&A session. For the participants who want to ask, please raise your hand first and I will call your name. And then I will give you permission to unmute your audio. And also turn on your video directly to ask your question. Okay, to Mr. Didit Kusuma, you can ask your question. Don't forget to tell your name and your company or station, okay?
Okay, thank you. Sorry, I cannot use my camera because there is some trouble in my laptop. Okay, thank you, Mas Akbar, for a very good presentation. I'm Didit from the Petronas. I have several questions to you. The first one, can you show your slide that shown the clay mineral distribution for the triangle, Mas Akbar, that you made by Nita and Mas Akbar? Yeah, this one. Yeah. So my question actually, basically, why are you using the Cowley net and Elite comparison? As we know, based on the clay mineral evolution, the brittleness between the Cowley net and Elite is very far. Maybe can you explain any reason why you choose to use the Cowley net and Elite comparison? This is the first question. And the second question, my question actually, based on your project and or your presentation in Baung Shale that you present before, with this reservoir is frac or not? If this reservoir is frac, it's just the single frac or multi-state frac. And the last question, based on your experience, which multi-mean or probabilistic method is doing well for shale hydrocarbon interpretation, especially for define the mineral, probabilistic to define the mineral in shale gas or shale hydrocarbon. Thank you.
Okay, thank you, Mas Didit. This is my good friend actually from Petronas. Mas Didit is always a really good quality questions, but I will try to answer my best explanation here. Mas Didit, for your first question, this is really good as well. I really agree with you. At that time, I don't really agree to use the Cowley net and Elite in the same line because the behavior is totally different. I don't know in the geological evolution, but from the microscopic point of view, this kind of behavior is totally really different because Cowley net is Elite is normally produced like a pore bridging, and also it's sometimes make the ductility increase or the brittleness will be decreased. This kind of plot, actually, it wasn't plotted by me. It was plotted by the colleague who was working in the petrography analysis. But I also that I mentioned they were doing this kind of the line measurements. But I was at that time I was not really agree to use this kind of Cowley net and Elite in one line. So that's why I told you what I want to do. Take the consideration. I need the clay as less as possible to make sure that our shell will be in the good quality. Even in the 50%, you can see it's really rare. The clay contents is more than 50%. Let's say you can see Marcellus and some of the Three Fork in here, but actually the clay is kaolinite. It's not Elite or smectate or even chloride. So that's why it still have a good one. But for us, Actually, this is not kaulinate. Most of them must do it. This is elite. So that's why I'm not really sure as well if we have high clay content in this lower bound sections with really high clay. It will be bad. Second question about the fracturing in the previous project. Unfortunately, I don't know what was the reasons. As far as I know, it wasn't frac. Actually, the most important one, when we want to see the quality of the shell, even the oil or the gas shell, at least we need to do the fracking. If we don't have enough budget for the fracking, let's say we can do the radial jet, high pressure radial jet at this moment. But unfortunately, this kind of measurements was not really good, because when you do the radial jet high pressures, the porosity, the pores or the fracture was created. It's not hanging by the propan, so that's why it will be easily back to the normal. So it's really recommended that Mas Didit mentioned it should be fracking. But at this moment, at that time we didn't do any fracking on it, and it's unfortunately this was the missing part. Yeah, this is the good homework for us. Later on, when we are trying to drill the new wells, we need to do the fracking to see the potential of the reservoir itself, because the organic which already trapped inside the shell, there cannot flow because there is no conduits to make them flow. If we just considering the permeability from the matrix system, it's extremely low, which is really low. It could be around nanodarcy. And you know, the gas, normally the rule of thumb that we use in the oil industry, the gas can flow maybe around 0.1 millidarcy, which is a 1,000 or maybe 10,000 higher with the current situation in organic matters. What was the third question, Mas Didit? Multi-mineral analysis, sorry.
Yeah,
So talking
probably.
about multi-mineral analysis, it should be really recommend if we have the mineral composition as well from the laboratory measurement, let's say from the XRD at least, and also we have the TOC content from the rock eval pyrolysis, and also maybe from LECO. And whenever we have the TOC, we converted the percent volume, and then we are incorporated with the XRD in the percent volume, and later on when we do the probabilistic or well logging inversion based on the multi-mineral considerations, we have to match every single lithology, every single minerals. After all of them match, and then we will consider the result of the interpretation. Whenever they are good, it also depends on the inversion process, which is depend on the standard deviation from each well. And what we need, I will take the consideration at least 10% error from the standard deviation in every single log from the probabilistic method. That's my recommendation so far, Mas Didit. Maybe Mas Didit has another experience on it. Thanks for the question. I hope it's answered your question.
Okay, thank you. Enough. Thank you, AAPG. Thank you, Mas Akbar.
Thank you, Mas Didit. I give it back to Ainun.
Okay, is there any question? So the participants who want to ask, just raise your hands or just chat to me. There is a question from Mr. Hendra via chat. Number one, there are 4 questions from Mr. Hendra. The first one, Please collaborate more regarding NMR related to T1 and T2 with time when occurred and T2 cut off in shale gas. And then number 2, what kind clay structure should be targeting for shale gas?
Okay, just two of them.
Okay.
Because I have a really short memory.
Okay.
So thanks, Mas Henry, for the question. It's really good questions for the NMR especially. So actually there was some recommendation as well from our service company at the times to see the possibility not only from the T1 and T2, but also with the diffusivity in order to see the fluid types of the shells. I'm not really sure as well because we are dealing with extremely low porosity. If it's possible as well, maybe if we have a quite high carbons and the maturation is really good, maybe we can see from this kind of the T1, T2 diffusivity crossplot to see the fluid type and the maturity as well. But unfortunately at that time, we didn't do that one because the NMR processing was not conducted by us. It was conducted by our services. What we received at that time, it's already interpreted. And the second about the T2 cutoff, it's also really difficult to answer actually. There is no specific T2 cutoff was used, so that's why it's similar like a trial and error that previously used in the previous study. And also I tried to find some of the papers as well. So far the T2 cutoff was also doing by the trial and error and tried to consider by sense which one is more reliable to be used. The second one, maybe there are some the T2 measurements or the NMR measurement based on the core. But unfortunately, when you do the core measurement based on the T2, we have a different resolutions. We have a different situation. We are in the surface. It's also quite difficult. We cannot use apple to apple the T2 cutoff from the cores that we implemented to the log, because first we have a different frequency. The second, we have a different resolutions. The third one, we have a different conditions of the borehole and also from the surface. So I think this is like how to say, it should be based on the best sense and the experience someone who works in the shell itself. What was the other question? Can you mention, Ainan? I hope this answered the question.
Number 2, what kind of clay structure should be targeting for shale gas?
Clay structure.
Yes.
So actually we are not targeting with the clay. We are targeting with the shell, which rich of the quartz or rich of the carbonate, let's say calcite or dolomite. In what we need, we really that I show you in the previous slide. Sorry. Here, what they have, they are totally focused with the shell, with the high or quartz content or the carbonate content instead of the clay, because the clay is the poisons. Whenever we have the clay, at least it's a kaolinate clay, but for me as well, clay is a clay is a poisons. So that's why instead of we have shale, which the dominant composition based the carbonate and the quartz, it will be a good candidate for being good unconventional, not the clay itself.
Is that enough?
Yeah. That's all from me.
There are 2 questions. Number 3, is there any log analysis to predict gas absorption quantity rather than estimate SW? And the SW that you shown in PPT are calibrated with score SW or absorption gas.
Okay, so the SW was measured based on, it's just not my research, it was a study from the Xu et al. In 2017. So the water saturation was provided by Xu in the core. It was the water saturation considering the adsorbed saturation as well. So what we need for the, it should be take note that the adsorption isotherm from the Langmuir test, it's different with the adsorption saturations that we have in the pores. But that's what could be estimated, because in the Langmuir isotherm, it's a quite huge resolution, which is we are calculating how many volume of the gas can be stored or can be absorbed in the standard cubic feet of the gas over the 1 ton of the solid. So actually this was used for the CBM investigation, but it's also taken into consideration for the storage calculation in the organic shale. But if you are dealing with the saturations in the shale that I mentioned previously, that water saturations in the shale, it should be taken into consideration, because this is from the Xu. This is the water saturation from the conventional measurements, and this is the water saturation considering with the organic content. You can see there is a difference. The difference is around 20%, and it's also make a good significant as well to do the calculation of the measurements. And from this study as well, it was also a good proof. But for calculating the adsorb with how many percent from the logs, so far there are just the straight relationship between TOC with the adsorbed gas volume. But this is the last information that I have. We just do some strike relationship, maybe multilinear or just linear relationship to see the relation between TOC and the adsorbed gas volume in the SCF stone. That's all.
And there is the last question. What kind of mud system formed the well that you analyzed?
Sorry, mud system?
Yes, mud system.
You mean the mud
From
was
the well.
used? Okay, unfortunately, when we were doing some project, the mud was used is the oil-based mud. When the oil-based mud was implemented in the drilling and also for the wireline well logs, the cuttings was taken to the surface. It was also contaminated with the oil-based mud. And this oil-based mud, when we bring to the lab, we have to clean this oil-based mud. When we try to do the cleaning that I told you in this slide, some of the organic content was washed as well, because we are trying to clean the hydrocarbon itself, try to clean the oil-based mud, but unfortunately some of the kerogen or the organic content was clean as well. So yeah, we use the oil-based mud at that time. But this is also like a contradiction as well, because we are dealing with the shale. We are afraid if we have a kind of swelling clay, let's say montmorillonite was remaining there, maybe some swelling will be created if we're using the water-based mud. So that's why this kind of, and also some of the logs also working well with the oil-based mud. So it's a kind of the contradiction that we have to sit together in the same table, what kind of mud it could be more reliable to be run. That's all.
Okay, thank you, Mr. Akbar. And then there is another question from Mr. Amjad. The question is, what is the relationship between organic porosity and TOC and the heterogeneity effect?
Heterogeneity effect. Okay.
Yeah.
What is the relationship between the porosity between the TOC? Okay. Because I explained you in here, in the porosity, we have two kind of porosity in unconventional. We have free porosity from the conventional matrix system, which is an inorganic matrix. And we have a porosity relating with the absorbed porosity, which is the pores inside the kerogens, and also the porosity. I can say it's like a porosity because I told you the kerogen itself, it's containing the gas which absorb. So inside the kerogen itself, we have free pores and adsorb. And this is absorb pores is it's staying in the surface of the solids. And this one, it could be identified based on the Langmuir isotherm, how many gas is adsorbed in the surface of the rocks. And from here, we have to consider that what we have from the logs, it's the density. The density logs from the ROBI, it's calculating everything, calculating the free gas and calculating the total of the adsorb as well. So if there is a relations, yes, from the smokers, because this absorbed gas is relating with the the adsorbed gas is relating with the TOC from the smoker study, and this one, okay, and the TOC was a quite good relation with the density. So whenever density has a relation with the porosity, and now density relation with the total organic content, and total organic content has a relation with the adsorbed porosity, so I can say they have relations. I don't know what kind of relations. It depends on our investigation. Every study has a different behaviors, but this is the good way for us for doing the research. That's all.
Hey, thank you, Mr. Akbar.
You're very welcome.
There's only 10 minutes left for this Q&A session. So if you want to ask, you can raise your hand or write it via private chat to me.
Waiting question from the Unpad section.
Is there any question?
Bahasa Indonesia juga boleh kok. Kalau ada
Ya.
yang nanya. Oh, yang protes sama bahasa Inggris saya juga nggak apa-apa.
It's good, Mr. Akbar.
Kalau nggak ada yang tanya itu kan ada dua. Satu paham sekali, yang dua tidak paham sama sekali.
Yeah. Is there any questions from the participants? I will wait until 3 minutes. I think there's no question, Mr. Akbar.
I just read some of the comments. Thanks for the participant. So I think it's okay if you want to close this meeting. You can go further. Maybe there is no question anymore from the
Participants.
participants. So
Yeah.
I give it back to you. Yeah.
Okay, thank you, Mr. Akbar, for the amazing lecture and the amazing discussions.
You're very
And,
welcome.
and now we will have a symbolic handover of e-certificate to Mr. Muhammad Nur Ali Akbar as our speaker for Online Continually Course second meeting from TRAPSPOT 2020. It will be given by Mr. Benedictus as the project officer of TRAPSPOT 2020. Mr. Benedictus, the time is yours.
Okay, thank you, Ainun. The Honorable Mr. Muhammad Nur Ali Akbar, Mr. Ahmad Yuski, all TRAPSPOT committee and participant, good evening. Let me introduce myself. My name is Benedictus Beril, as Project Officer of TRAPSPOT 2020, represent of all the TRAPSPOT committee. I'm going to give Mr. Muhammad Nur Ali Akbar a symbolic certificate because have filled this course with amazing and useful material for all who have attended to this course. Thank you to Mr. Muhammad Nur Ali Akbar for the amazing materials. Thank you. I return it to Ainun. Thank you, Ainun.
Thanks a lot for the appreciation. Ainun, you're still muted, Ainun.
I'm sorry. Now is the closing speech will be given by Mr. Benedictus as the project officer of TRAPSPOT 2020. Mr. Benedictus, the time is yours.
Okay, thank you again, Ainun. Perhaps this is the end of our online continually course as one of the TRAPSPOT series. So that's all I can say as project officer. No more or less as well as mistakes that I said either intentionally or not. I really apologize. TRAPSPOT still has the big event that is National Seminar. Don't forget to register and come to our big event. Thanks to Mr. Nur Ali Akbar as speaker, Mr. Ahmad Yuski as AAPG President, all participant, sponsor, and media partner. Thank you. I return it to Ainun again. Thank you.
Okay, Mr. Benedictus, thank you for your closing speech. Today and now, before we end this activity, we will have a session photo first. All the participants are required to turn on the video for the photo sessions and use the background zoom. I will give you 1 minute to prepare your video and turn on your video.
Sorry, my connection was bad.
Pardon?
Sorry, my connection was distracted.
It's okay. Okay, so to all participants, please turn on your video and use the background zoom, please. I'll be waiting for 1 minute. Okay. Okay. Are you guys ready? If you can't use the background Zoom, it's okay. But it is better if you use the background Zoom. Okay, I think the time is going by, and I will accept of you guys. Please smile. The screenshot will be taken by our committee. I will say it in 1, 2, 3, or maybe 1, 2, 3 in Indonesian. I will say it in Indonesia. Okay, the first page or the first slide. 1, 2. Okay. The next slide. 1, 2. Okay. Okay. Yang ketiga. 1, 2, 3. And then the last one is, okay, 1, 2, 3. Okay, thank you. And I would like to say thank you so much to Mr. Muhammad Nur Ali Akbar for the marvelous lecture, and also thank you for all the participants who had joined the second meeting of Online Continually Course. Now we are at the very end of today's event. On behalf of the organizing committees, we would like to apologize for any mistakes throughout today's event. I hope the second meeting will expand your knowledge about introduction to petrophysical analysis for unconventional shale reservoir. And thank you to our sponsor, which are Petrochina, Chevron, Pertamina Hulu Simenggaris, and Medco INP Simenggaris, and also media partner by Radio Mahasiswa Unpad, Geologipedia, Event Mahasiswa 8, Bandung Event Bandung.id, Geologinet, and Event Campus. See you on the next of TRAPSPOT 2020. Thank you, and wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Thank you, Mr. Akbar.
Thank you very much for all our participants. Thanks, AAPG Unpad. I'm glad to be here. I'm glad to be shared to you. See you next time.
Okay, see you, Mr. Akbar.
Thank you so much, Mr.
Thank you so much for Mr. Akbar.
So guys, I just remind you, if you have some questions, you have some discussion, just in touch with me in the LinkedIn or even Facebook is okay. Okay. So I have to leave. I have another meeting now.
Ah ya, semangat Pak. Makasih ya Pak.
Keep safe for the COVID situations.
Iya Pak.
Belajar yang semangat ya. Dadah, assalamualaikum warahmatullahi wabarakatuh. Saya izin pamit.
Terima kasih Pak.
Terima kasih Pak.
Bye.
Terima kasih Pak.